Circle theorem 3. Angles in the same segment. Now this angle here and this angle here. What's so special about these two angles? Well, it brings us to circle theorem 3, that angles in the circumference in the same segment of a circle are equal. Why is that so? If you look at it, let's go back a little, is that this angle here, this angle, standing on this at this point and this point. Okay, so let me just label those 2 points quickly. Get that quickly. So we have this point, point A, right here. And we have another point down here, point B. This angle right here is standing on the point A and standing on point B. And do you notice that this angle here in the same segment is also standing on point A and B? Yeah. And so what do we know about these two angles, therefore? Okay, well, we see they're standing on the same segment. Why is that? Because if you should draw a line, a chord that is, if you should draw a chord, just take that out quickly. Straight down here. Okay, it should be a chord, it's not straight. Okay, if you draw a chord here, then this chord separates the circle in 2 segments. This segment here, which is the minor segment, and this segment over here, which is the major segment. So these two angles are in the same segment. And angles in the same segment, according to this theorem, are equal. Okay, so let's look at that again in another fashion. Okay, if you notice, the same two angles that we have here are standing on the same points A and point B. We can also see they are actually in the same segment because this line here separates the circle, cuts the circle in 2 segments. The minor segment and the major segment. And notice this is the light blue is the major segment. So these two angles are in the same segment, and angles same segment according to circle theorem 3 are equal. Yep, the pale green area is the same segment. So what does that imply? Even the other way around, if we should draw a line here, that cuts the circle in 2 segments, this segment here is minor, and this bigger part is the major segment. And these two angles are in the same segment, so they're equal. So those two are equal. Those two are equal. So these two angles are equal because they're the same segment. If we should draw a line here, a chord here that separate the circle into 2 segments, the major segment over here are equal. If I should draw a chord here, then this segment down here, these two angles down in the same segment will be equal. And if you think of it, we have 2 triangles being formed. So if this angle is equal to this one, and this one is equal to this one, what about these 2 angles? All 3 angles should add to 180. And so these 2 angles must be what? If you said the same, then you're correct. But we can also think about line properties that when you have 2 straight lines cross each other, this line here crosses with this line here, then the opposite angles, the vertical angles that are opposite are equal. So this angle and this angle will be equal. But also from the standpoint that the 3 angles in the triangle must be equal. So if these 2 are equal to these 2 respectively, then these 2 angles will also be equal. Hence the white face. So Circle theorem 3 is that angles at the circumference in the same segment of a circle are equal. Angles at the circumference in the same segment are equal. All right, so let's test you now on this. So I'm going to ask you this question and you're going to try to do some work here rather than just listening to me. So we have this angle right here. So let's call this angle A. Let's call this angle B. Let's call this angle C. Okay, let's call this angle D. Angle A is 30, angle B is 40. What is angle D? What is angle C? You can pause the video, work it out, and then tell me. Okay, so solution, this angle here should be 40 degrees. And the reason is that these two angles are in the same segment. Should you draw a straight line from here to here? This would be a chord that cuts a circle in two segments. So these two angles will be in the same major segment. Should I draw a chord right here that cuts the circle into the minor segment and the major segment? Then these two angles down here will be equal, so this must be 30 degrees as well. Now what angle is this? What is this angle here? Can you figure that out? You can pause the video and then come back and tell me. Okay, so if this is 30, this is 40, what is this angle? Well, we know that all three angles must be summed to 180 degrees. So if we have 180 degrees, and the sum of these two angles is 70, how much more do we need to get 180? Well, we can take the 70 that we have so far, subtract it from 180, and that will give us 110 degrees. So 110 plus 70 give us 180. This angle is 110 degrees. Hence, what is this angle here? Well, if these two angles match these two angles respectively, then these two angles must match. Because sum of angles must add up to 180 in this triangle as well. And also we can look at the standpoint that when two straight lines cross each other, vertically opposite angles are equal. These two angles will be equal, and these two angles here, in it. This angle here equal to the value of that angle there as well. Okay, and so that's about it.